Download this code from codegive.com, link in the description below. OK, let's dive into the world of test coverage, test-driven change, TDC, and how they intertwine to create robust and reliable software. This will be a comprehensive guide with code examples in Python, but the principles are applicable to other languages. Introduction, the essence of test coverage and test-driven change. Test coverage, a gauge of testing depth. Definition. Test coverage measures the extent to which your tests exercise, or cover, the different parts of your code base. It aims to quantify what percentage of your code is actually being executed when you run your tests. Why it matters. High test coverage is not a guarantee of perfect code, but it significantly reduces the risk of hidden bugs and makes refactoring much safer. If tests don't touch a section of code, you have no automated way of knowing if changes to that code break something. Conversely, low test coverage leaves large portions of your application untested, making it difficult to catch defects early in the development process. Common metrics. Test coverage is usually expressed as a percentage for various metrics. Line coverage. Percentage of lines of code executed during testing. Branch coverage. Percentage of conditional branches, example if/else statements, for loops, while loops, taken during testing. Important because if statements can have at least two paths that need to be tested. Statement coverage. Similar to line coverage but may differentiate between multiple statements on the same line. Function coverage. Percentage of functions or methods called during testing. Condition coverage. Checks that Boolean expressions within conditional statements are evaluated to both true and false during testing. Path coverage. Tests every possible execution path through a function or program. Generally impractical for anything but very simple functions due to combinatorial explosion. Test-driven change, TDC, is systematic approach to code improvement. Definition. Test-driven change is a specific process for modifying code that emphasizes the role of tests at every step. It's about using tests deliberately to guide your changes and ensure that you're moving in the right direction. It is a more refined version of test-driven development, TDD, specifically for evolving existing code. The key principles of TDC. 1. Identify a small, well-defined change. Don't try to rewrite the entire system at once. Focus on small, incremental improvements. 2. Write a test that exposes the need for the change. This test should fail initially. This confirms that the test is testing what you think it is. This failing test encapsulates the change you want to make. 3. Make the change. Make the minimum amount of code necessary to make the test pass. Don't add extra functionality or refactor until the test passes. 4. Refactor. Now that the test passes, you can refactor the code to improve its structure, readability, or performance without breaking the existing functionality. Your passing test suite gives you confidence that your refactoring is safe. 5. Repeat. Continue the cycle of identifying small changes, writing tests, implementing changes, and refactoring. Why TDC is effective. Reduced risk. Small, incremental changes with immediate feedback from tests minimize the risk of introducing bugs. Improved code quality. The constant cycle of refactoring ensures that the code remains clean, maintainable, and understandable. Increased confidence. A comprehensive test suite provides confidence in the correctness of the code, making it easier to make changes and deploy new features. 2. Setting up your environment. Python example. 1. Install the ptest testing framework **. Ptest is a powerful and flexible testing framework for Python. 2. Install the ptest COV coverage plugin **. Ptest COV allows you to generate coverage reports when running your tests with ptest. 3. Example code base, let's call this calculator.py. 3. Writing initial tests and generating coverage reports. 1. Create a test file, let's call this test_calculator.py. 2. Run tests and generate coverage report **. **ptest, runs the ptest test runner. *-cov equals calculator, tells ptest COV to measure coverage for the calculator.py module. This will output a summary of the coverage results in your terminal. It will tell you the percentage of lines covered. 3. Generate a detailed HTML coverage report **. This command will create an hgov directory containing a detailed HTML report. Open hgov/index.html in your browser to view the report. This report highlights which lines of code were executed by your tests and which were not. Analyzing the report **. The HTML report is invaluable. It shows you exactly which lines are covered and which are not. Uncovered lines represent areas of your code that are not being tested and therefore are more likely to contain bugs or unexpected behavior. 4. Applying test-driven change, TDC. Let's say we want to add a new feature to our calculator class, a power method that calculates a raised to the power of b. We'll use TDC. Step 1. Identify the change. We want to implement the power method, def power, self, a, b return ab. Step 2. Write a failing test. Run ptest COV equals calculator. The test_power will fail because the power method doesn't exist yet. This is good. We've confirmed the test is doing what we want. Also, the coverage report will show that the power method is missing, because it doesn't exist. Step 3, make the change, minimum to pass. Run ptest COV equals calculator again. Now all tests should pass, including test_power. The coverage report will now show that the power method is covered. Step 4, refactor, if needed. In this simple case, there isn't much to refactor. The power method is concise and readable. However, if the implementation were more complex, this would be the time to simplify it while maintaining the existing behavior, verified by your tests. Step 5, repeat. Continue this cycle for any new features or changes you need to make to the calculator class. V. Addressing low coverage areas, specific examples. Let's assume after the first round of testing, before adding power, your coverage report shows that the multiply method in calculator.py only has partial branch coverage. Specifically, the if a == 0 or b == 0 line hasn't been fully tested, you only tested cases where neither a nor b was 0. 1. Analyze the uncovered branch **. The coverage report indicates that the case where either a or b, or both, is 0 is not being tested. 2. Write a new test **. 3. Run tests and check coverage **. Run ptest COV equals calculator COV report HTML again. The coverage report should now show full branch coverage for the multiply method. 4. Addressing the division by 0 **. The division method has a check for 0, but the coverage tool might not consider it fully tested unless an exception is explicitly raised. Let's add a test that ensures that. 5. Using mutation testing to find unkilled mutants. Mutation testing is a powerful technique to ensure your tests cover the intent of your code. It involves making small changes, mutations, to your code and then running your tests. If a test fails after a mutation, it means your test suite caught the change and is therefore effective in covering that part of the code. If a test doesn't fail, the mutant survives, it means your test suite is missing a test to detect that specific type of error. Install mutmut. Run it against your code. Mutmut will then inject mutants in your code. You'll need to check each mutant that survives and add additional tests to catch it. 6. Advanced considerations. Mocking and patching. When testing code that interacts with external dependencies, databases, APIs, file systems, you'll often need to use mocking or patching to isolate your tests and avoid relying on real external resources. Libraries like unitest.mock, built into Python, are invaluable for this. Integration tests. While unit tests, testing individual functions or classes, are important, you also need integration tests to ensure that different parts of your system work together correctly. Integration tests typically have lower coverage than unit tests, but they're crucial for catching interface-related bugs. End-to-end, E2E, tests. E2E tests simulate user behavior and verify that the entire system works as expected from the user's perspective. These tests usually have the lowest coverage but provide the highest level of confidence in the overall functionality. Tools like Selenium or Cypress are used. Test data management. Consider how you manage test data. Use realistic but safe data. Automated test data generation can be very helpful. Continuous integration, CI. Integrate your tests and coverage reports into your CI pipeline. This ensures that tests are run automatically on every commit, and you can track coverage trends over time. Coverage thresholds. Set reasonable coverage goals for your project. Aim for high coverage, example 80 to 90%, but don't obsess over 100% if it leads to overly complex or brittle tests. 7. Common pitfalls and how to avoid them. Chasing 100% coverage at all costs. Focus on meaningful tests, not just maximizing coverage numbers. Sometimes, achieving 100% coverage requires writing tests that are excessively complex or that test trivial aspects of the code. Prioritize testing the critical logic and edge cases. Ignoring edge cases. Pay close attention to edge cases, boundary conditions, and error scenarios. These are often the source of bugs. Writing tests that are too specific. Brittle tests. Avoid writing tests that are tightly coupled to the implementation details of the code. If the implementation changes, the tests should still pass if the functionality remains the same. Use higher-level assertions that focus on the behavior of the code rather than its internal workings. Testing private methods. In general, you should avoid testing private methods directly. Private methods are part of the implementation and should be tested indirectly through the public methods that call them. Testing private methods directly makes your tests more brittle and less maintainable. There are exceptions, but this is a good guideline. Not updating tests when code changes. When you modify existing code, make sure to update the corresponding tests to reflect the changes. Outdated tests can be worse than no tests at all because they can give you a false sense of security. Ignoring code smells. High test coverage doesn't automatically mean that the code is well designed. Pay attention to code smells, example long methods, complex conditional logic, duplicated code, and refactor the code to improve its quality. 8. Conclusion. Test coverage is a valuable metric for assessing the quality of your testing efforts. Test-driven change is a powerful method to evolve a code base using tests to define what is to be changed. By understanding coverage metrics, applying test-driven change, and avoiding common pitfalls, you can create software that is more reliable, maintainable, and easier to evolve. Remember that testing is an ongoing process, and continuous improvement is key. Embrace testing as an integral part of your development workflow, and you'll reap the benefits in the long run.